Hi guys, welcome to part 2 of the mechanics exam from 2021. We're just going to continue from our previous video. So, question 2, around the bend. A rider rides around a circular bend of a radius 7 meters, don't know why it says mat, at a constant speed of 10 meters per second. Question A. If the combined mass of the rider and bike is 90 kgs, calculate the centripetal force required. Alright. On your equation sheet, you should have a formula that lets you find the centripetal force, and it should be Fc equals mv squared divided by the radius. So we put our values in. The combined mass is 90 times the speed, which is 10. So 10 squared over our radius, which is 7. That will equal 1,286 newtons, but we're going to round to the lowest amount of significant figures, which is 2 in our question. So our answer will be 1,300 newtons. And that is a simple achieved mark for us. Okay, next question. When the rider is in the position below, they bike across a very slippery part of the track. Okay, that's pretty important information. Use physics principles. So we know it's another one of those explain questions. To explain the path the rider takes when they bike across the very, I think that's meant to say, slippery part of the track. Show this path on the diagram with an arrow. So it's just going to be, a straight line, just like this. It's not an arrow to the middle because that's just the arrow of the centripetal force. This is just showing the direction that it's traveling. And yeah, we just got to explain. So what we can say is, if I zoom out a little bit, basically what's going on here is when the friction force, which is provided when the tires and the road or bike or the track or whatever come into contact, that friction force gives a centripetal force that keeps it in circular motion. But then when it reaches this very slippery part, that friction will be gone, okay? It just disappears. So there's no friction, that means there's no centripetal force, and then that means it won't be, traveling in a circle anymore, so the bike will just carry on in a straight line at a constant speed tangent to the circle. So let's write that down. When the biker rides across or over the slippery patch, it loses the centripetal force. I'll scroll down a little bit more. Provided by the friction force, which means it will no longer travel in a circle. So it will carry on in a straight line at a constant speed tangent to the circle. Okay, now the key words that we want to be covering is constant speed, straight line, tangent to the circle, and this part here. Okay, those are the key parts that we need to discuss. If we have all of this green, if you've talked about pretty much these green parts, all of them, you'd get a merit grade. If you talk about any two of the tangent or constant speed or the loss of the centripetal force or whatever, that would be an achieve. So yeah, just any 2 points. Alright, that is it. That's that question. Next one. The spring constant is 40,000 Newton meters. A rider of mass 80 kg sits on the bike, causing the spring to compress. Goodness me, heavy. Calculate how much energy is stored in the compressed spring. Alright, the first thing we need to do, so to find the energy, it's this equation. Alright, EP equals half of kx squared. That's on your formula sheet. Right now we don't have x. We need to find x. So the first thing we need to do is find x. Now, in x, we can find that using this formula. Alright, rearranging for it. But we don't have the force either. But they give us the mass, so we can find the weight force. So the weight force just equals mass times gravity. It's just going to be 80 kgs times 9.8. So F is going to be equal to 784 newtons. Just do that in my head. So to rearrange for x, so x just equals, move that negative k to the other side. Just something like that. So that negative in the equation, but it's not actually a negative when we put it in our calculator or thingies. It's just part of the equation. Don't know why, it just is. So when we put in the numbers, don't put in negative 40,000, just put in 40,000. So if you put that into your calculator, you should get 0.0196 meters, because x is the displacement in meters. So now to get the potential energy or elastic potential energy in the compressed spring, we have all the information we need. Now it's just plugging in what we found. So EP equals half of the K, which is, this is K, 40,000 times 0.0196 squared. Don't forget that squared. So EP will equal 7.68 joules rounded correctly. Alright. This is a merit question. So if you get this final answer and you also get this force value correct, you get a merit. If you get one correct calculation, maybe you just find, I don't know, the force. That's an achieved. Okay, next question. When a rider lands after a jump, they essentially have a collision with the ground. Again, this physics principles to explain fully how a suspension system makes a bike safer for landing. Alright, so these type of questions pop up a lot. Like every paper I've done, I've pretty much seen a question simple, pretty much the same sort of explanations as this, just in a different context. It's always the same. So when we look at the this equation here, this is the momentum equation. We want to rearrange it for F represents change in P over T. Now, this right here, this P, it always stays the same. So always constant. Okay? Which means if we increase our time, if we increase T, that means our force decreases, right? And if the force decreases, that means there's going to be less force on impact, and therefore when he lands, it will be safer. So we can write something like, what can we say? The suspension system increases. Oh, I don't know if I can fit that in. Oh, I know I spelled it wrong, but I don't care. Increases the time of impact. I'll write that. Which will decrease the force. Okay? Since change in P, or you can write it as change in momentum. Change in momentum is the same. It's the same. I'll just close that bracket off. Is the same. A smaller force results. You have to have a concluding statement on the safety. Is safer on landing. You could also write something, if you want to sound like a nerd, you can also write something like the spring absorbs the energy on impact, so that means less force is transmitted to the rider over a longer time, and that will ultimately reduce the injury or risk of impact or whatever. Alright, so this type of question here where it's asking you, it's always going to be this equation here, this effect. You just got to rearrange it, and then all you basically got to cover is the time increasing and what that will do to the force. That will decrease the force because the change of momentum is the same. So every single time this is an excellence question, it's like the easiest excellence question you'll get. Like this is, like, yeah, if you do enough past papers, you'll see this type of question pop up a lot because it's repetitive as hell. If you get merit, you have to have two correct statements. So maybe if we just had like, I don't know, if you just increases the time of impact, which will decrease the force, that's a merit. One correct statement for achieved. So literally just this part here. Just suspension system increases T. Whatever. Alright, that's achieved. So yeah, that's question 2 done. I'll do question 3 another day, but as usual, if any questions, feel free to message or leave a comment. And yeah, cheers.